Okay, so today we are going to be looking at 3D shapes. We're going to be looking specifically at finding the volume and the surface area of 3D shapes. Okay, so it's going to be our last bit of our 3D geometry. And then next lesson, we'll be moving on to doing vectors. Okay, so we're just a little bit behind with the schedule. So vectors will be in the next session in 2 weeks' time. Okay, so 3D shapes, let's have a start by looking at the volume. Now, there are two different types of 3D shapes. There are prisms, and then there are pyramids. There are also spheres and stuff, so there's more than two types. But the two main types that we look at are either prisms, and that's anything like this, okay, or a pyramid as well. So in a prism, we can always find the volume of a prism by looking at the area of the cross section, and that's the bit that is colouring in now. So you can see the cross section of this cuboid here has just turned green, and the cross section of this triangular prism here is blue. Okay, so it's always the cross section and then multiplied by the depth or the length of that prism. Okay, or sometimes the height of the prism. So you can see that the volume of this prism here is kind of made up of that green cross section all the way through. It's the same cross section all the way through there. And this triangular prism here is that blue triangle, and it's the same shape all the way through. Okay, so once you know the area, you can just multiply it by the length of that depth there. Okay, so let's have a look at doing that with a cuboid. So a cuboid is going to be the area of the cross section, which in this case could be either the height times the width there, or if we took this shaded side to be the cross section, it would be the height times the depth, and then multiplying that all the way through by the length. Okay, so taking the height times the width to be the cross section, we've got height times width, and then multiplied by the depth there. So the volume of a cuboid is very easy to find. Just literally multiply those three parameters together. Okay, units for volume then is our unit for whatever the length we're using, centimeters, meters, millimeters, cubed. Okay, we're multiplying three parameters together, so we've got three sort of things we multiply together, so it becomes cubed. Okay, when we multiply two parameters for area, it's squared, and multiplying three parameters for volume, it becomes cubed. So to find the volume of a shape, we're thinking about multiplying three different things together. So we're thinking the units is going to be height centimeters multiplied by width centimeters multiplied by depth centimeters. So we've got the cubic centimeters there. Okay. Right, so let's go straight ahead and have a look at an example. And in this example, the volume of this cuboid, we've got a width of 4, a length of 3, and a height of 12 there. So to find the volume of this one, we're simply going to multiply the width by the height by the depth. And we've got 4 times 3 times 12. Okay, so the volume of this one is going to be 144. And then we've got centimeters cubed for that one. So we'll go straight ahead and move on to another one. Another example there, I'll just give you a moment to have a go at this one. Pop it in the chat if you want to write the answer. It's just a quick warm up. Get you started. If you do think you've got the answer, pop it in the chat. Hopefully you've got a calculator on you. If not, you should be able to do it without a calculator. A bit more effort. Great. Okay. Yeah, we've got our first answer. That's really good. Well done. Okay, so volume of this one, 7 times 9 multiplied by 3. Okay, so that's going to be 189 centimeters cubed. So thank you for popping that in the chat, and correct. Well done. Okay, so let's have a look at a more complicated prism. So this time we've got a triangular prism here. Okay, triangular based prism. So this one has a cross section of a triangle. So to find the area of the cross section here, we're going to have to remember how to find the area of a triangle. And the area of a triangle is going to be base times height divided by 2. You should remember that formula, base times height divided by 2. the area of a triangle, okay? So putting that in then, we're going to first of all find the area of the cross section. That's 11 multiplied by 8 divided by 2. So that gives us 44 centimeters squared for the area of the cross section. And then multiplying that by the depth, we're going to multiply that whole area by 20. And we've got 44 times 20 comes to 880 centimeters cubed. So that's the area of the cross section, that's the area of the triangle, multiplied by the depth. With any prism, no matter how complicated the shape, if you find that area of that cross section first, it's really then easy to find the volume, just multiply it by the depth or the height or the width, the length of that prism, okay? So let's have a look at this one. This is a more complicated one because we can't just get that area of that cross section straight away. So you might look at a question like this in an exam and think, oh my goodness, there's quite a lot to do here. But if you just follow that trick, if you just find the area of that cross section first, then you can literally find the volume really easily by multiplying it by the width, okay? So how are we going to find the area of this cross section? Well, we're going to need to split it up, okay? It is a cross shape and we don't have a formula for the area of a cross, but we do have a formula for the area of a rectangle. So we can take this cross section and we can split it up, and I'm going to do that by going straight across here and across here. And I'm going to make two small rectangles, A and B, or A and C rather, and one bigger rectangle, B, there in the middle. You could have chosen to split it up by going vertically down here. Totally up to you, but that's how I've chosen to do it, okay? So in the exam, don't spend long thinking about it. Just grab your ruler, have a look. Can I do it this way? Is it the kind of easiest way? Doesn't make a huge amount of difference here because I'm splitting it into 3 rectangles that way. If I'd gone vertically down, still would have been splitting it into 3 rectangles. So it doesn't make a lot of difference, okay? So in this question, I've now got, okay, I've got a rectangle here that's 4 by 1 centimeter. I've got this rectangle here, which is 7 centimeters by 1 centimeter here, 4 centimeters here, and then this big arrow here tells me the whole thing is 6. So it's technically 7 by 6 centimeters. That's B. And then my A rectangle is going to be 4 again, and by 1 this time. Okay. So let's have a look at working them all out separately. And in an exam, it's a good idea to really clearly show the working for each separate rectangle. So the area of A is going to be 1 times 4, which is 4 centimeters squared there. The area of B was going to be 7 by 6, which is 42 centimeters squared. And the area of C is going to be 1 by 4, which is 4 centimeters squared again. Okay, so now we've got those 3 areas of the rectangle. We can work out the area of this whole cross section. So that's the next step, is to work out the area of the whole cross section by just adding the areas of those 3 rectangles together. So we've got 4 plus 4 plus 42, A plus B plus C there, okay? So total area of the cross section there is going to be 50 centimeters squared. Now that we know that, that's most of our work done for us. The final step, simply to find the volume, is to multiply the area of the cross section by the length, by the depth there, which is 14 centimeters, okay? Someone sent in the answer and it's correct. Well done. Thank you, Meadow. Volume is 50 by 14, which is 700 centimeters cubed. So fantastic work. Well done. Great to see. Now, you don't need to remember the volume formulae. They are in the formula page at the beginning of that exam book. Okay, here. So the volume of a prism that we've just been looking at, area of cross section by length, is given here in this section. But you've also got other formulae for volume. So if you are given another shape, a different shape, you can look back to that formula page and find the formula for the volume there, okay? So you don't need to remember them, you just need to be able to use them. I think it's an absolutely, let's just have a look at this cone. I think it's an absolutely fantastic, that just works out really well that a cone is actually exactly 1/3 of the volume of a cylinder. Okay, I just think that's a really cool fact. So any cone, if you sort of imagine that you wanted to take a cylinder and cut a cone out of it by just cutting off a corner there and a corner there, you'd end up with 1/3 of that cylinder. So that's a really easy way. If you do need to remember how to find the volume of a cylinder. Well, a cylinder is just a type of prism, okay? So it is literally the area of the cross-section, which is a circle, multiplied by the height, okay? And then the volume of a cone is literally 1/3 of that. So it's just a nice little way of remembering that. And a sphere, 4/3 pi r cubed, okay? So the volume of a sphere is 4/3 pi r cubed, but you do have that information in that formula page, so you can refer back to that if you need it, okay? So with that there, then you just need to be able to substitute values into the formula. So let's have a look at a past exam question together, okay? So in this exam question, and we'll give you a bit of time just to have a look at it as well, but I'll read it to you. The diagram shows a cuboid and a cylinder, okay? So we've got two different shapes, 3D shapes here. The dimensions of the cuboid are x by 12 by 5 centimeters. The volume of the cuboid is 270 centimeters cubed, okay? So you've got a bit of information in this question just telling you what's in the diagram, but then you've also got a bit of information in this question which actually gives you some extra information to what's in the diagram. So it's really important that you read the question carefully, because if you miss that bit, then you are going to miss some quite important information there. So I'm just going to highlight that bit there. Okay, I'm just going to use my pen to highlight the volume there. It's 270 centimeters cubed, really important bit of information. We're then told that the radius of the cylinder is x and the height of the cylinder is 2x centimeters. And we're asked to find the volume of the cylinder. Okay, so to do this, we're going to need to use this information first. We use this cuboid first to find the value of x. So let's put the information into, like, make a little equation. I love to make equations, okay? So the equation, the volume of the cuboid is 270 centimeters squared. How am I going to find the volume of that cuboid? Well, it's going to be depth times width times height, so x times 12 times 5. So the volume of the cuboid is going to be x times 12 times 5, and we're told that that's all equal to 270 centimeters cubed. So I've created myself a little equation here, and then I'm going to tidy that up, and 12 times 5 is 60, so I've got 60x is 270. And finally, I'm going to solve that. I'm going to solve that to find the value of x, okay? Does anyone want to pop x into the chat for me? Tell me what x is. Or if you don't have a calculator, you could at least tell me how to find x. What do I need to do there to find x? Brilliant. Yeah, 270 divided by 60. Fantastic. Thank you for that. So 270 divided by 60 is going to give us 4.5. Okay, that decimal point isn't so clear there, but it's there. So 4.5 centimeters. Just look back and check. That does make sense, okay? If I had somehow made a mistake there, if I had thought, oh gosh, I've written 45 centimeters, probably wouldn't make a whole lot of sense there. Just fitting it almost back into this diagram. 4.5 looks about right. Okay, so now that we've got 4.5, we can write that in here. I will go ahead and write that in. So x is 4.5 there. But the more important thing is actually writing it in here. 4.5 here and 2x here. So 2 times 4.5 there. Okay, so that's actually going to be equal to 9 centimeters. And now that we have that information, we can find the volume of that cylinder. So the volume of a cylinder, it was on the formula page, but you should also be able to know it because you know that the area of a circle is pi r squared, and then it's multiplied by the height. It's exactly the same as another prism. It's a circular prism. So it's the area of the cross section times by the height. So it's going to be, volume of the cylinder is going to be pi times x squared multiplied by 2x. And substituting those values for x in, we're going to have pi times 4.5 squared times 2 times 4.5, or 20.25 pi times 9. Okay, so then going ahead and putting all of that into your calculator, you get 572.555, and then look back at this point, always look back at the question. Did they ask me to give the answer as in a particular way? And yes, they have. They've asked us to give the answer correct to the nearest whole number. So it's going to be rounding up to the nearest whole number, which in this case is 573 centimeters cubed. Okay. So that was just a kind of volume exam question for you. Does anyone have any questions there before I move on? No? Okay. I'll just get rid of those drawings. Okay, right. Moving on for the moment from volume. Oh, was this a foundation exam question? Let's have a look. I honestly don't, I think it was from higher. Yeah, I'm pretty sure it was from a higher tier paper. However, it could well have been from a crossover paper, because that could be asked at both foundation and higher. The skills there that you need are valid for both foundation and higher. Okay, good question though. Right, surface area then. So surface area is actually the one that's a little bit more complicated. Okay, surface area is kind of finding the area of the shape all the way around the outside. So imagine if you wanted to paint the outside of this cube, how much space would you need to paint, basically, okay? Now with a cube, surface area is looking just at 6 equal squares, okay? Because a cube is made up of 6 equal squares. So with surface area, it's all about knowing what faces make up that 3D shape, okay? So this particular cube is made up of a square here that's going to be 5 centimeters. And we know because it's a cube that they are all the same. So I could go ahead and I could write 5 centimeters in there. And I could write 5 centimeters here as well. Okay, so I know that this cube is 5 by 5 by 5. But the biggest mistake made in exams, I've seen it so many times, when people are, a little bit stressed or a little bit nervous and they're just trying to, get all the information in their head that they can, it's very tempting to just go ahead and find the volume. So you've got to read the question really, really carefully and make sure if you see the word surface area, if you're asked to find the surface area, find the surface area, okay? It's different to finding the volume, but going ahead, like a lot of people will just think, oh, I need to multiply them all together. So we're not going to be multiplying them all together in this particular case. Ooh, turns out I'd already done that, so we can clear those. There we go. So we've got 1 square A, that's 5 times 5, okay? So area of A is 5 times 5. And then we've actually got 6 equal squares on there. So it's going to be 6 times 25. So the total surface area here is 150 centimeters squared. Okay. Sometimes they're going to be a lot more complicated. We've got here a triangular prism, and we're asked to find the surface area of this prism. So it's really important now that we can actually break this shape up into what sort of faces it's made up of. So let's just have a look at this shape. It's made up of a triangle. This one here is a triangle, and there's another triangle at the back there, okay? And those 2 triangles are the same. It's a prism, so we've got the same shape going all the way through. So those 2 triangles are equal. And then we've got a rectangle here on this side. Imagine if you were sort of standing here and looking just there, you'd see a rectangle. You've got a rectangle on this back there, okay, on the back. Imagine if you were standing behind it and looking at it, you'd see a rectangle there. And then it's actually sitting on a rectangle as well. So it's got 5 faces, 2 equal triangles, and 3 different rectangles, okay? So let's have a look at how we're going to solve this. Now the area of the triangles are going to be half. So we did an area of a triangle earlier, it's half base times height. So it's a half times 5 times 6. So that's a half multiplied by 30, which is 15 meters squared. Look out for the units there, we've got meters. And we've got 2 of those, okay? So there's actually 2 triangles exactly the same. So I can multiply that by 2, and I've got 30 meters squared for the area of the 2 triangles together. Then I've got 3 separate rectangles. So let's have a look first at this rectangle that's out here on the front, okay? So this big kind of exposed one. So this is 12 meters by 11 meters, okay? So I can see that this longer side here is the height of my rectangle and 12 is the length. So 12 times 11 is 132 square meters. The area of rectangle 2, that's the one it's sitting on. So now I can look at what it's sitting on. I can see that the length of the rectangle is 12 meters and the width of the rectangle is 5 meters. So that's, excuse me. Ooh, excuse me, I had to sneeze there, sorry. That's 12 times 5, okay, so that's 60 meters squared. And then finally, this kind of hidden rectangle at the back, that is, let me have a look. So it's this dotted line, which is the same as this. So it's 12 meters. And then multiplied by 7, this diagonal line here, okay? So that was 12 times 7, which is 84 meters squared. So I'm going to go around and I'm just going to check. There's 5 faces, 2 are triangles. I've done those 2 here, and 3 rectangles. So I have got all of my areas covered. Once I've done that, then I can go ahead and I can add those together. So the total surface area is going to be those 5 different areas added together, and it's 306 square meters. So you can see there's a lot more work to do in surface area, especially something like this. You've got a lot more kind of to work out, different faces to find the area of and things to work out. Surface area questions on their own in an exam do tend to have a few more marks. So always, you know, if you do a volume question and you've just multiplied 3 things together, and then you think, oh gosh, I've got 5 marks for multiplying 3 numbers together, have a look back. How can you get 5 marks for multiplying 3 numbers together? That should be a 1 or a 2 mark thing. So you need to check back and just see, where did those other marks come from? What have I done? Should I have done something else? Okay. So I always find it's a really good tip in the exams to look at the number of marks and think, have I done enough work? Have I done the right amount of work for these number of marks? Okay. Do we have any questions on that? I feel like I'm going very quickly today, but I'm also really sorry. I'm also just sort of firing information at you. Okay. No, good. That's great. Thanks. Okay, let's continue on then. So here we go. I've done another one. And I just thought I'd give you kind of a minute to just have a go at doing this one on your own, because there's quite a lot to do with surface area, quite a lot to think about. So I'm just going to give you a minute to have a go at this one on your own. If you want to write any questions, pop them in the chat there, and then I will put the answer up on the screen for you. You should be able to do this without a calculator, but honestly, go ahead and grab one if you want to. It's Edexcel IGCSE, isn't it? So there's no non-calculator paper in this one. So I'd recommend always having it handy. If you want to pop the answer into a chat once you've got it, please do go ahead and do so. Brilliant. Okay, we've got our first answer. Right. Charlotte, I believe that's correct. Well done. So have a look. Maybe I think you've missed one rectangle there, Meadow. So maybe just have a look. I can pop the answer up for you now. Actually, a few people have put answers in the chat, so well done. Just double check that you've got the right answer by looking back and seeing, have I included all of the information? So the triangle here, 6 times 3. Okay, remember it's half base times height. So it could be that you didn't multiply the triangle, the base times height by a half there. If you, yeah, okay, you figured it out, well done. So yeah, when you do a surface area question like that, it's so easy to just miss one face. So just count how many faces have I done and then check that it matches the number of faces on the shape, okay? So 3 times 6 is 18 divided by 2. So the area of the triangle is a half times 3 times 6, which is 9. But there are actually 2 triangles there. So those are 18 together, okay? So we've got 2 triangles, the front and the back make 18 centimeters squared. This kind of top rectangle is 7 times 10. Oh, no, it seems I've done the bottom rectangle first on here. So bottom rectangle is 6 times 10, okay? 60. This top rectangle here is 7 times 10, it's 70. And this back rectangle here is 3 times 10, it's 30, okay? Finally then, now we've checked, I've got 3 rectangles and 2 triangles. I can add those together. And the final answer is 178 centimeters squared. Okay, so fantastic work for getting that answer. Well done. One final thing I'm going to talk about before, I don't think I've put this in a question, but I do want to talk about it. It's very, very common in these kind of questions to get, in fact, I might do something I've not done before and just share a whiteboard a second and just draw. You have to, I'm going to apologize right now for my terrible drawings because, but I'm just going to draw a kind of what you can get quite often, which is something like this, where you've got a, this is going to be a 3D shape. Oh, that's not really a 3D shape. But the idea is that you've got, oh gosh, it's been a long time since I've drawn things like this with so much technology and stuff. But the idea being that you're given a 3D shape, so you're given a pyramid, a prism like this, and you're only given, say, a not quite enough information. So I might be given that this is, I'm just going to put this is 4 centimeters. So this side is 4 centimeters. The height there is 3 centimeters. And I'm going to say that this length is 11 centimeters. So what we've got here is a very badly drawn, and I do apologize for that. It's meant to be the exact same shape as I did before. So it's meant to be a 3D prism, but we have not been given all of the information. I've been given enough information to do this kind of base triangle. Oh, so I've given enough information to do the area of the 2 triangles. The area of the triangles I can do. Okay, they are going to be a half times base times height. So that's a half times 4 times 3, which is a half times 12, which is 6 centimeters. And then, of course, I've got 2 of them. So 2 times 6 is 12 centimeters. Okay. I've been given enough information to do this kind of back rectangle here. I'm just going to shade it so you can see it. Okay. That one is going to be 3 by 11. So this rectangle 1 is going to be 3 times 11, which is 33 centimeters. I've been given enough information to do this bottom rectangle, the one that it's sitting on. Okay, that's going to be 4 times 11, So rectangle 2 is 4 times 11, which is 44 centimeters. But what I've not been given enough information is this one. I'm going to call it rectangle A. It's this one kind of facing the sky. Can anyone see and write in the chat for me, what bit of maths would I have to use next? How would I find in an exam this side here to get that so that I can now find the surface area of this shape? This is quite a common question, exam question. And I do apologize for the terrible drawing. Not very easy to write on here. You can think of what bit of maths. A bit of maths, a theorem named after a wonderful Greek mathematician. Brilliant. Thank you, Meadow. Pythagoras. Excellent. Okay. So I have been given a right angle triangle here. That's the important bit. Been given a right angle triangle. So I know that I can use a bit of Pythagoras. So I can come over here and I can say, wow, I don't know what this side is, but I'll call it X. And I know that 3 squared plus 4 squared equals X squared. And then working that all out, we've got 9. You probably don't even need to work this out because in your head, hopefully you recognize that pattern for that triangle. But if you don't, it doesn't matter. 9 plus 16 is X squared. And then that's going to be 25 is X squared. So X is 5 centimeters. So now that I know that X is 5 centimeters, then we can work out that last rectangle there. So that rectangle, I'll call it rectangle 3 just for, is 5 times 11, which is 55. And then I can go ahead and add my 2 triangles and my 3 rectangles together for that surface area. So that's a very common question where you have to use a little bit of Pythagoras within your surface area question. So I just thought I'd throw that one out back. Okay, any questions on that? I'll go back to sharing my slideshow. Okay. Right, so let's have a look. What we've got here is a different type of prism. It's a kind of, it does have a special name, this is a parallelopiped, I think. I think I said that wrong, but it's a parallelogram prism. Okay, so a prism with a parallelogram as its cross section. Okay, so remember, we're not finding the volume, we're finding the surface area. Okay, so to find the surface area of this parallelogram, we need to know a few things. We need to know how to find the area of a parallelogram. Okay, do we remember how to find the area of a parallelogram? It's a bit of a tricky one. It's kind of a bit of a trick one here, because we're given this 9 and we're given this 8, but it's not actually the 8 that we multiply by a parallelogram. The area is the base times the perpendicular height. Ooh. Okay, so it's the base times, let me draw that on there, the perpendicular height, which is this one. And we can actually see from this diagram that the perpendicular height is given here, it's 7 centimeters. So it's a bit of a trick question there. Whether you were finding, even if you wanted to find the volume, you would need to use that area of parallelogram. So just just be aware of that, okay? So the base times the perpendicular height is the area of the parallelograms. And then again, we've got 2 of them, we've got one at the front and one at the back, okay? I hope I've remembered to add that on at the end. Let's come back to that and hope that I've done that right. Now I'm going to have a look and I'm thinking, well, this parallelogram has got 4 sides. So that means I've got 4 different areas. So I need to make rectangles. So I'm going to have to make sure I do 4 rectangles. Okay. Although they're not 4 different rectangles, you'll see in a minute, because its parallelograms have that wonderful property of having equal length opposite sides. And that is, again, something you might draw on there when you're in your exam. You can draw all over the diagram. This side is 8 here, which means that this side is also 8. And this base is 9, so this top is 9. Okay, very important when we're looking at the different rectangles we've got. So the area of rectangle here on the base is 9 times 11. And that's actually going to be exactly the same as the area of the rectangle on the top. And then the other rectangle we've got is this area. Oh, I have multiplied that one by 2. Okay, so that's got the area on the base and the area on the top there, 198 centimeters squared. And then the next one, we've got the area of this rectangle 2. So that's going to be 8 times 11. So it's 88. And again, we've got one on the side there, and we've got an identical one on the side here. This is also 8 times 11. Can get a bit confusing, but of course, if this is 11, then by this must be 11 as well. Okay, so that's 8 times 11. So we've got 2 of those. Total surface area then. Oh, look, I did. So, you know, you've got to just really double check your work with these. It's so easy to make a mistake. I should have multiplied that by 2. So I should add on another 63 here to get the right answer. So I do apologize there. I've made a mistake there. The total surface area should actually be 500 centimeters cubed. Okay, it's a lovely round number answer. 500 centimeters squared, my apologies. This is surface area. So it should give the cubic, it should give the units for area, which is centimeters squared. Okay, so sorry about that. I did make a mistake at the beginning. I forgot to multiply my parallelogram by 2, but by going back and checking your work, you'll sort of find these mistakes, and that's really important in maths. It's so easy to make mistakes. Okay. Let's clear those drawings off. Okay. This is another question I just wanted to talk about, a cylinder. So the surface area of a cylinder. I often tell my students to sort of go home and grab a tin of baked beans or something like that and look at what the shape of the area of the cylinder is, okay? So if you imagine a cylinder, I'm going to try and draw, not very well, kind of looks like this. All right, if you imagine your tin of baked beans, you've got a circle at the top. You've got a circle up at the base. So you've got 2 circles, and then you've got this kind of shape here around the outside of the tin of baked beans. And that would be the label, and imagine your kind of label on your beans. So what happens if you peel that label off? So if you peel that label off, you actually get a rectangle, okay? So your shape, or your net of a cylinder, is going to be a rectangle, and then of course it's got those 2 circles like that on it, okay? So the curved surface area of the cylinder is the bit that refers to that label that you've peeled off the baked beans, okay? And then the whole surface, the total surface area would be that plus the top and the bottom of the cylinder. So how would we find the area of just that curved surface area? You've got to really read the question carefully. So that's all it's asking for in here. Well, the curved surface area, I think I've done this. Oh, there we go. Is going to be equal to, it's going to be that rectangle. I'm going to need to think about, well, how will I know what the length of this is? But if you imagine that this rectangle is unpeeled from the baked beans, okay, you've unpeeled that rectangle, that label from the baked beans, the length of this, I somehow deleted that, that's not what I meant to do. The length of this rectangle is going to be actually equal to the circumference of the beans, okay? The circumference of the circle. So we need to remember, how do we find the circumference of a circle? The circumference of a circle is equal to 2 pi r. So the curved surface area of a rectangle, of a cylinder, sorry, is equal to 2 pi r multiplied by the height of that cylinder. So it's equal to 2 pi r h. And then how would we find it? Well, we just multiply it together. So 2 times pi times the radius, so that's 2 times pi times 0.56 multiplied by 1.6, okay? So that's 5.6297. And it says here to give the answer in meters squared, correct to 3 significant figures. So rounding that to 3 significant figures is 5.63. So that's a really important thing. I think, I'm going to just flip back actually, I think that was also in, it'll take a while, I'll go back like this. let's have a look at that formula page. Curved surface area of cylinder is actually given on that formula page. It's given here. So you don't need to remember it, but it's really important you do remember kind of what part it represents. And it represents this, it's actually technically a rectangle. It represents this bit that goes all the way around the curved bit there, okay? So you can just substitute it in 2 times pi times r times h, but you must remember that. So I'm just going to do a question now. I'm going to do a question given a cylinder, okay, with a radius of 5 centimeters and a height of 10 centimeters. Let's keep it simple, okay? What's the total surface area? The total surface area is going to be the curved surface area. Add the top and the bottom, the circles on the top and the bottom, okay? So it's going to be a total curved surface area, add 2 lots of the circles. I'm going to write that out so you can see. Now the curved surface area is what we've just talked about. It's imagining opening that label from the baked beans tin, okay? So, or you can look at the formula book and just see it written there. It's 2 times pi times r times the height plus the circle on the top and the circle on the bottom of that tin, okay? And area of a circle is pi r squared. Lots to remember, I'm afraid. There's pi r squared. So 2 times pi r squared. So the total surface area of a cylinder, I always like to, because it kind of has a ring to it, is 2 pi r h plus 2 pi r squared, okay? Substituting all the information we have in then. So it's 2 times pi, sorry, that's very messy. Let's do that again. 2 times pi times the radius, that's 5, times the height, that's 10, plus 2 times pi times the radius, that's 5 squared. And then you can just get your calculator and find the answer, okay? So it's just remembering that formula, or even just being able to picture the net of the cylinder, okay? And I will go ahead and have a look at the answer. So it's going to be 50 times 2, so it's 100 pi plus 25 times plus 50 pi, it's 150 pi, which is 471.2 centimeters squared, okay? It's a surface area, so it's centimeters squared, or you can always just leave it in terms of pi if you prefer, okay? Any questions on that? I've thrown cylinder in there quite quickly. Does anyone have any questions? Got about 10 minutes left, which is enough time to do the last exam question that I wanted to do. I'll just find it by going back to... Yeah, I think it's here, wasn't it? I wanted to just do this question. Okay. I just found this exam question. I just thought this would be quite a good question to look at because it's worded and it's quite sort of a lot of detail in it. And I think a lot of people might just look at this and think, oh, I haven't got a clue how to start it. Jane has a carton of orange juice. The carton is in the shape of a cuboid. Okay, so we've got a cuboid here. And then the depth of the orange juice in the carton is 8 centimeters. That's a very important part of the question there. I'm going to highlight that. The depth is 8 centimeters. Jane closes the carton and turns the carton over so that it stands on the shaded face. And it says, work out the depth in centimeters of the orange juice now. I think it's quite a sort of tricky question. If you're sat in an exam, you're trying to visualize doing this. It can be quite tricky to know where to start. And honestly, the first place I would start in the exam is I would take this depth of 8 centimeters and I would draw that on the diagram, okay? So it's a carton here, it's 6 by 10 by 20 centimeters. But you can imagine, if you imagine it's a see-through carton, you can see the orange juice in it. The orange juice would go up to around about here, wouldn't it? The depth of the orange juice is 8, so that would go to about there. Okay, so that means that this much is orange juice and the rest is kind of just air. Now, what's going to happen later is she's going to turn that carton over, and of course all the juice will go to the bottom. So what we really need to know is how much orange juice is in there. How much orange juice is in that carton? Okay, so that's going to be the volume. So it's a volume question of orange juice, the OJ, all right, is going to be 6 times 8. 6 times 8, and then multiplied by 10, okay? So we've got 6 times 8, the area of the cross-section multiplied by the depth, 10 now, that's the volume. So we're going back to the volume for a moment, okay? Working that out then, so that's 6 times 8 times 10. Shouldn't have to use a calculator for this, should I? Should be able to do that in my head, I'm very sorry. 480 centimeters cube, okay? So you've got 480 cubic centimeters of orange juice in that carton. So that gives us the volume of orange juice, but that's not the final answer. We actually want to know when she turns that carton, when she flips that carton over and stands it on its shaded face, how much orange juice is in there now, okay? So the shaded face is this front face. So it's going to be this 6 by 20 face, okay? So it's now going to be still a cuboid, it's still the same cuboid, okay? But it's now going to be 6 times 20 on its base there, with its kind of 10 centimeters going up like this, okay? So that's 10 centimeters there, all right? Badly drawn again, I do apologize. My drawing on 3D shapes used to be much better than this. And when I spent a lot of time practicing them on the board, got terrible now. But you get the idea, and honestly, in the exam, it doesn't matter. The point is just that you kind of have a visualization for it in your head. Now, all of that orange juice is going to have fallen, so it's going to once again be kind of at some point here. So there's going to be a line there where your orange juice goes up to. Okay, and that I'm going to call X. I like using X in when I work out these things. Okay, so there's going to be a kind of new cuboid of orange juice inside that carton, and the volume of orange juice has not changed. That's the important part. I've still got 480 cubic centimeters of orange juice. So I need to find the depth, okay? So now my new volume is going to be 6 times 20 times X, and that's still going to be equal to 480 centimeters cubed, okay? So I've kind of, once again, like we did at the beginning, formed myself an equation that I can solve. So neatening this up, then simplifying, I've got 6 times 20, which is 120x. It's equal to 480. So X is going to be 480 divided by 120, which is 4 centimeters. Okay, so hopefully you can see how a question that might initially look a little bit confusing can kind of be broken down, and you can work it out just doing it bit by bit. So thinking, what do I need to know first? What do I know next? Okay, and it's a volume question.